Hello everyone. Welcome to the next part of topic Kinematics of Particle. In the previous topic, we gone through that part rectilinear motion from the kinetics of particle. We saw its different theory parts related with the rectilinear motion. So now in this video, we are going to see the numericals related to this rectilinear motion. So in this rectilinear motion, let us see that first numerical. Here that diagram is given for the numerical, and that is mentioned that motorist is traveling 54 km per hour when she observes that a traffic light 240 meter ahead of her turns red. The traffic light is timed to stay red for 24 seconds. If the motorist wishes to pass the light without stopping just as it turns green, then determine first part that the required uniform deceleration of the car, and second the speed of the car as it passes the light. So from this given numerical, first of all we need to list down the given things, that what different things are given to us. Like here first we can observe that traveling at 54 km per hour means the speed of the vehicle is given 54 km per hour. To solve the problem, we need to convert this speed into meters per second. So just 54 into 1000 divided by 3600, it will give you its value in meters per second. Then next thing is mentioned that traffic light is 240 meter ahead, means the distance is given 240 meter. So S we can consider as 240 meter, and then the traffic light is termed to stay red for 24 seconds. It means the time is given, that is t is equal to 24 seconds. So when we are going for the solution, first of all mention all the given things, that the distance, velocity. Now in velocity two types are there, initial and final. So as here it is given that the vehicle is traveling with the given velocity, it means that is the initial velocity. Hence this velocity is mentioned with letter u, that is initial velocity, and it is converted into its value meter per second. So that is 15 meters per second and time. So in solution, the first part we are asked, so for that first part we are using this equation that S is equal to ut plus half at square. So just put these values over here. We are asked to find out the deceleration of the car. So then here the one question is how to choose this equation, because we have three equations. So out of the three equations, which one is useful? So just have a list of all the three equations and check one by one that how many things are given for all those three equations and what is asked to find out. Here we are asked to find out this A, that is deceleration, and this S is known, T is known, initial velocity is known. So I chose this equation that S is equal to ut plus half at square. Put here all the given values. So just one unknown is there, so we can get this one unknown by solving this one equation, and that value of A is becomes minus 0.417 meter per second square. As this A is having minus sign, it means it is deceleration. In question also the same thing is asked, that find out the deceleration of the car. Then next to that we are asked that we are asked that velocity by which it will cross the signal. So for velocity we have another equation that v is equal to u plus at. Even the remaining equation that v square is equal to u square minus twice as, that can also be used, because there a, s, v, u means that instead of u all the things are known. But here I have used that equation v is equal to u plus at. So in this again put this u is equal to 15, a is equal to this minus 0.417 which is obtained by the first equation, and then t is equal to 24. So there we are getting the velocity, that is 5 meters per second. Likewise this question can be solved, and here we are getting all the asked thing, means all the answers. So this 5 meter per second velocity is converted into kilometer per hour, that 18 kilometer per hour. Likewise these questions can be solved. Very easy to solve it. In these types of questions, just remember that we are having only three equations with us, and based on those three equations only we need to solve the problems. No other equation is to be used. So whatever the three equations are there, that S is equal to ut plus half at square, then v is equal to u plus at, and the third one v square is equal to u square plus twice as. Just based on these three equations, you will get the answer. Nothing other than these three equations used to be used in these types of problems. This was the problem related to the horizontal motion in the rectilinear type. Next to this, we will see one more problem for the vertical motion, that is motion under gravity. But when we are going for this motion under gravity, there is some sign convention. What is that sign convention? Let us see that. So it is explained with the help of this diagram. And what is mentioned, that a ball thrown vertically upward. So this is the release point from where the ball is thrown upward. So this point needs to be treated as the origin. And for this origin, then the further things are to be mentioned, or in fact their sign conventions are to be mentioned, means whether the velocity is plus or minus, or the distance traveled is plus or minus. That thing is based on this origin. So with respect to this origin, the first thing, when this ball is traveling upward, it means its x will be plus, that is the displacement will be plus, and the velocity will also be plus. When this ball will reach to the maximum height, its velocity becomes 0 and its displacement is still positive. After that maximum height, it is returning back. Even it is returning back, its displacement is positive, but now its v will become negative. The point which is in the same line as that of the release point at this location, here now x will become 0, that is the displacement will become 0, but the v is negative. And next to that, when the ball is moving towards the ground, or when it will reach to the ground, that x will be treated as minus. Why this minus? Because now this ball is traveling the distance below this point of projection. And as our normal sign convention is there, that all the positive upward quantities are positive and downward quantities are negative. So in the same manner, but just below this reference point, as that ball is traveling the distance below the reference point, x will be taken as negative and y is obviously negative. And based on this, these things are mentioned, that displacement is positive or negative based on the location. Location means this point of release, or that is the origin. Then velocity is positive or negative based on the direction of motion. If it is moving upward, then it is plus. If it is moving downward, then it is minus. And acceleration is gravity, which is always downward. This acceleration, it will be only because of the acceleration due to gravity, that gravitational acceleration g, and hence it will always be negative, that a will always be written as minus g. Okay, so from this category, let us see the next problem, that second numerical. For this second numerical, it is mentioned that a stone has fallen a distance of 12 meters after being dropped from the top of a tower. Another stone is dropped from a point 20 meters below the top of the tower. If both stones reach the ground together, find height of the tower. Now here the diagram is not mentioned. So given with respect to this given statement, this diagram is drawn. Here the first thing is given, that a stone has fallen a distance of 12 meters after being dropped from the top of a tower. So that point of drop is considered as the origin, means that top of the tower is taken as origin. From this origin, this first stone is dropped and it is covering the distance of 12 meters. So this is taken as the initial point A till point B, that stone 1 is covering the distance of 12 meters. Then secondly, another stone is dropped from a point of 20 meters below the top of the tower. So this is the top. Below that 20 meter distance is taken, and from that the second stone is dropped. Now both of these stones are reaching to the ground together, and hence we are asked to find out the height of the tower. So we have assumed that total height of the tower is h, and hence this distance is becoming h minus 20. And as we are dropping that stone, means initially the stone is at rest and then we are dropping it, that is why the initial velocity of the stone is taken as 0. Now how to solve this problem? So for that, the first equation is written, that stone 1 is dropped from the top of a tower. When it reaches the 12 meters below the top, that is at point B, its velocity is taken, that is the final velocity, that Vb square is equal to us square minus 2gs. Now for velocity we have one more equation, that v is equal to u minus gt. But in that equation t is not known. That is why instead of that equation, here we are using only this equation where these things are known. Now u means that is the initial velocity. We are just dropping the stone, so initial velocity is 0. 2 into g is already known, 9.81, and s, it is covering the distance of 12 meter below the point of projection. That is why this distance is taken with minus sign, that is minus 12. And hence here that VB is obtained as 15.34. But as that stone is moving downward, this VB is shown with the downward direction. Then that time is assumed as t, which is the time taken by the second stone to reach the ground, that is from point C to point D. Therefore, that time taken by stone 1 from B to D must be t seconds. Means what we are mentioning here, from this C to D we are saying that it is time t for second stone. That is why for the first stone also, because both of the stones are reaching at the same time to this D point, hence the time from B to D, that is also considered as t. So that is the time t. For this time t, then that motion is taken from B to D for stone 1, and the equation is considered s is equal to ut minus half gt square. Why this equation is taken? Because here s is known, u is known, g is known, and only t is unknown. That is why this first equation is taken. And now this h, it is equal to h minus 12. It is covering the distance of 12 meter and the total height is h. Hence the remaining height for time t is h minus 12. And as it is below the point of projection, this minus sign is taken. So it is equal to u. This u means, now this is that velocity. So now this velocity at point B will become the initial velocity. Hence that initial velocity, and as it is in the downward direction, again it is with the minus sign. This minus 1 by 2 into 9.81 t square. So this final equation is written as 15.34 t plus 4.9 t square plus 12. This is the first equation. Here h and t both are the unknowns. Let us go to the second part of this solution. Now for second stone, that motion is from C to D. So for C to D, again the same equation is considered, but here now s has become h minus 20, again with the minus sign. U is again 0, minus half into 9.81 t square. So this equation becomes h is equal to 20 plus 4.9 t square. This is the second equation. In this equation also there are two unknowns, h and t. So just equating equations 1 and 2, we can get this final equation, which is the quadratic equation in terms of t. These terms will get cancelled and there will be only one term related with the t. So hence that t is obtained by solving this equation as 0.52 seconds. Put this t either in the first equation or in the second equation. So I have put it in the second equation to get the value of h. And by putting this t here, I have obtained that value of h. This is the total height of the tower, 21.33 meters. Likewise, you can solve any numerical related to this rectilinear motion, that too again uniform motion. In this uniform motion, you just need to use these three equations. Always keep it in mind that s is equal to ut plus half at square, v is equal to u plus at, and v square is equal to u square plus twice as. And for motion under gravity, just replace that a with minus g. And just by using these three equations, you will get the answer. This is so simple to solve these numericals. So for your practice, some more examples are given here. You can solve these examples and you can cross check your answers, that what answers you are getting. It is based on the same explanation what I just have given. So thank you for listening to this session. If you have any query, you can drop me a mail on my mail ID and accordingly we can solve your queries. Thank you once again.